So far in this course, we've just leaned on all of the existing publishers that Combine gives us and some of the extensions in Foundation. But sometimes we need to create our own publishers, and doing so is deceptively simple. The reason why it's deceptively simple is publisher is defined as a protocol that has two associated types. There's a type alias for the output type, which we've seen, and there's a type alias for the failure type. So any publisher that we create is going to have to define what these two are. And in addition, there's also one other function called receive, and we'll see the signature for that in just a second. So I say that it's deceptively simple because these are the only requirements for us to define a publisher and allow it to compile, but there's some additional rules we need to consider in order to play nicely in the Combine ecosystem. And namely, that is correctly responding to demand, or otherwise known as back pressure. If we don't do this, then we're not necessarily a good Combine citizen, and it can actually cause other things not to play nicely with our publisher. So whenever we're making a publisher, we want to make sure that, unless we're absolutely certain, we want to make sure that we're handling demand properly. So as an example, let's make a publisher, and I'm going to call this random number publisher. So that's going to implement the publisher protocol. And that means that I need to have a type alias for the output and define that as int, and a type alias for our failure type, and I'll define that as never. So the only other thing I need to have is this receive function. This receive function is going to receive some subscriber S, where S implements the subscriber protocol, and then the failure type matches our failure type, and the output type of us matches the input type of the subscriber. Now, a quick note about this. We've talked briefly about the fact that publishers can be structs or classes. And the main deciding point that you'll have is whether or not you need this to have reference semantics and therefore share its subscription with multiple subscribers, or if you want each to receive their own. So unless you specifically need a class, I would say start with a struct here. Okay, so what we need to do is we need to create a subscription, something that implements the Combine's subscription protocol, and tell the subscriber that it has a subscription. So usually that is done by having an extension on your type. So we'll say random number publisher, and then inside of here, we'll have a final class subscription, and this is going to implement combine.subscription. And you can call this whatever you want, but I call it subscription because it kind of makes sense that it's a subscription inside of this type. But because I use that word, I have to fully specify the protocol subscription coming from the Combine framework. So at this point, it's saying it doesn't conform to that. And this is where we get a request and a cancel method. So let's delete these real quick. So now back up here in our random number publisher, when you initialize this, I may want to specify the range. So that'll be a closed range of integers. And then also maybe an optional count of how many numbers to produce before continuing. So that means that I'm going to have a range here, closed range of int, and a count, which is an int here, and initialize those to those results. Okay, so this is essentially all we need to do in our publisher. We're going to create a subscription. So that's going to be a new subscription. And I can pass it some arguments if I need to. And then I can tell the subscriber that it needs to receive a subscription. So I pass the subscription on to the subscriber. At this point, the subscription is the one doing all the work. This is the one that handles cancellation, and this is the one that handles the demand that the subscriber is requesting. So really all of the logic goes inside of this, and as long as this is alive, it's going to continue to be producing its values. And so really all we need to do is pass these values into our subscription, and that's kind of a common pattern where we'll have to basically copy any of these configuration options or arguments that we need for our subscription to work. We need to just pass them along. So we'll pass in range as range and count as count. Now, the next thing we need to do is pass the subscriber into the subscription as well, because the subscription is going to be the one hanging on to the subscriber and needs to know when to cancel, and that's going to essentially know when to clean everything up. So we're going to have a private var subscriber, which is some optional s. And that means that when we pass this in here, I'll say subscriber like that, this needs to be a subscription generic over some s that is a subscriber, and we'll add our generic constraints where our output type matches the subscriber's input type and where our failure type matches s's failure. So essentially the same thing that we did up here. So then we can pass in the subscriber here, which is going to be some s, and say self.subscriber equals subscriber. Okay, so the next thing we can do is cancel. And cancel is actually really easy. We just need to set our subscriber to nil. And that's going to clear up our reference to that subscriber, which is essentially what we need to do to clean up any memory. Now we're also going to have to see if we have a subscriber inside of here, because we don't want to start delivering values if we don't have a subscriber. So one thing we need to think about is this is the initial demand that the subscriber is asking for. Now, demand is a really interesting type. If we go look at that, so I hit Command, Control, and clicked, and then I'll hit Control 6, and we'll go to demand. So demand is essentially something that looks very much like a number. It's equatable, it's comparable, you can do math on it, but it also has things like unlimited and none, and it has maximum with a value. So the idea is that if you say that you can support a maximum of 5 values, then that's enough for our subscriber over here to say, or our subscription to say, okay, I'm free to deliver 5 values. Now, every time I deliver a value, let's say I say x equals 1, and I say subscriber.receive input. I need to pass in that input. So here it's x. That actually gives me back a new demand, because the subscriber can say, okay, I got one more, so maybe it frees up another slot and returns .max1. And one thing to note about demand is you can never subtract demand that you've already given to the subscription. So if it says give me 5 items, I'm going to give it 5 items if I have 5 to give. And it can respond with more demand, but it can't respond with less demand. So what I basically need to do is take the demand I have and add that demand onto the end. So what that means is I'm going to have, some demand that we work with locally. So I'm just going to make a mutable copy of it like this. What we can do is we can check to see if the demand is greater than 0. In fact, in this case, because I can just generate the values right away, I can use a while loop for that. So while the demand is greater than 0, we can subtract 1 from demand. Then we can give the subscriber its value. So let's create a quick function here called generate random number, and this will return an integer. And here I can use int.random in range. And so here I can say let value equals generate random number. And now I can ask the subscriber, or I can tell the subscriber to receive that value, and that's going to give me some new demand. Now, the new demand may very well be 0, but it's got to return something. So at this point now I can take the demand and add it to new demand by saying plus equals, like this. Now it is worth noting that we're in dangerous territory here of triggering an infinite loop, so I'm not going to run this just yet. Okay, so we also need to know what happens if subscriber is nil here. Well, I don't even want to enter this loop if subscriber is in here. So I'm going to say while let subscriber equals subscriber. So if subscriber is ever nil, we need to jump out of this loop. Let's fix up the spelling. So while I have a subscriber, I can enter this loop, and while I have demand, I can enter this loop. Then we'll subtract 1 from that, we'll generate a random number. Inside of here, I can unwrap, or I can use this as an unoptional, which means demand is now a value and I can add it to here. So if we entered this, say demand was 5, now demand is 4. And let's say that the subscriber said, give me 1 more. So the new demand is 1. Now demand is 5 again. So if this, let's say the subscriber had some sort of internal buffer where it always allowed 5 items, then this is kind of how it would function. And we would continue to iterate and deliver values as we have them to the subscriber, and the subscriber would say, okay, now I have room for 2 more. So in essence, the subscriber is entirely control over how many values it receives. Now, if the subscriber said give me unlimited, we'd have a problem here because unlimited minus 1 is unlimited. So we still need to figure out what to do in that case. We could continue to deliver values forever, but because we're in a tight loop here, this would essentially overload our playground with an infinite loop. In some cases, this is fine because there are publishers that have inherent limits to them. Like for instance, publishers that go get a value from the network or fail, and they deliver the value to you and then finish. So in our case, we're actually going to have to keep track of our count as well. So after we've sent a value to the subscriber, we can take our count, and if I make that count a var, now we can say count minus equals 1. And if the count is less than or equal to 0, then at this point we're done. So now we just need to tell the subscriber to receive its completion event, which in this case is finished. Now, in order for me to break out of that loop, I need to set self.subscriber to nil, because otherwise we'll tell it finished, but then we'll try to send values again. And that would be sort of a violation of the contract. There's nothing to tell the compiler that we're not honoring the publisher contract, because there's nothing in the protocol definition in Swift to enforce that we never send any values after finished. That's just an inherent contract that we have to adopt into when we're writing a custom publisher. Okay, so at this point, we say, here's some new demand. If we'll subtract the count, we'll do that. I'm just going to move this demand up so it is kind of close to that, because it doesn't really matter where we add this. And I'll delete these comments here. Okay, so at this point, if we've delivered the amount of values that we passed in with count, then we can tell the subscriber it finished, set subscriber to nil. It'll jump back up to this while loop and breakout. Okay, cleaning that up a little bit. Now let's go ahead and use this. So what we can do is we can create a random number publisher with a range of 1 to 100. And let's say I want 5 items. Then we'll say sync, and we'll receive completion and value. So here I'll print out the completion, and I'll also print out the value. Okay, and now we run it. We see we get 5 random numbers, 1, 2, 3, 4, 5, and then a finished event. So this is the basics of handling back pressure. In this case, it is handled by a while loop and a generator function that knows how to get the values. But if this is driving off of something asynchronous, you could use dispatch queues here. You could use whatever you want to go deliver the value, send it to the subscriber. So essentially any kind of asynchronous version of this would be doing the same pattern, but it would essentially be broken apart into different methods and handling the demand that way. Now, one thing I want to point out is that now that we're talking about custom publishers is earlier when we talked about threading, we talked about receive on to be able to receive these values on a given queue. So I could say dispatch queue.main. But there's also subscribe on, which up until this point didn't really make a lot of sense, dispatch queue.main. So why would you want to call subscribe on? Or maybe I want to say subscribe on a global queue and then receive on dispatch queue.main. So why would I want to do this? Well, if we go back and look where we are calling subscribe, we go over here, we create a subscription, and we tell the subscriber to receive that subscription. So this entire code here, if this code had to talk to a file or decode an image, or if this had to do any kind of heavy lifting, then maybe you want that type of work to happen on a background thread. Maybe it's opening a connection somewhere. And so basically, the subscribe on tells the combined pipeline what queue to be on when you actually create the subscription. Now, in our case, we're not doing any work inside of here, so it doesn't really make sense for us to do that. But that is kind of where that becomes valuable. And then the other end of this is when you receive on, that is when we call subscriber.receive. So notice that even if we were on the background queue here, we don't need to do any kind of queue management ourselves because the subscriber is entirely in control of that. I don't need to call dispatch queue.main.async every time I call back to the subscriber, either for a value or for completion. It's always going to receive those on the queue that it wants to, if it wants to specify that. So I wanted to point that out because this is kind of where those values actually make sense, is when you're creating a custom publisher. Okay, so what do we do if our random number publisher can fail? So let's say that if the number is divisible by 3, then we have a bad number. So I'm going to create a struct called bad number error, which is going to implement the error protocol. And now our random number publisher can possibly handle a bad number error. So it can fail. So an interesting thing to note is that now our publisher can fail. We have to have a completion part of the sync, whereas before we could have omitted it if we wanted to. Okay, so next we need to take a look at the value that we get out of here. And I could say, actually, what if we just made that inherent to this? So this is going to become a throwing method. So I'm going to add do catch around here. So this is now going to be a throwing method. And I'll say let value equals that. And if the value is a multiple of 3, then we're going to throw a bad number error. And then I need to return value. So now we've got this kind of fake error. And what do we do here? I need to essentially break out of this loop again. So I need to tell the subscriber that it completed. So it received completion, and this time failure with the error that we're handed in the catch block. And then similar to this, I also need to break out of that loop, because once you're completed, you shouldn't send any more values. Okay, so at this point now it's saying I can't convert the type of error to bad number error. I know that that's the only thing that can ever happen here. And so I can say that maybe I only catch those types of errors, or I can say as bad number error. And because I know that that's the only type of error that we're throwing, I think this is fine to do. Alternatively, we could only catch those errors in here and maybe add another catch that handles any other error and call fatal error there, but I think this is a little bit cleaner. Okay, so with that, now let's increase our number to increase the chances that we'll get that, and we'll run it, and we got 32 and 17, and boom, bad number error. So I don't know what the number actually was that was divisible by 3, but it does work, and this does show how we can kind of halt the chain when we're doing that. Now, the other thing I want to mention is, let's say we only want the first value out of this. So let's do that. And I also want to call print so we can see what's happening here. So at this point, now we take a look at the print output. We receive a subscription for this random number publisher. The subscription is, this generic thing that has print in it. And then it requests unlimited values. So that's the demand that first is requesting. And this may be a little bit surprising. For me, it was actually really surprising. I would have assumed that first would say, please give me 1 item. But instead, first says, I don't care how many items you have. I request unlimited items. And then when the first item is received, it cancels its upstream subscription. Sometimes these operators don't exactly behave as you might expect, and I'm not sure why they do it like this, but I'm sure there is a reason. Another thing to think about is if I say object at or output at, say 3, and let's make this is multiple of 15 or something, so just to make it a little bit less likely. So at this point now we receive our subscription. It requested unlimited values. We received 71. So that was the first value. Then output at this operator here requested 1 more item. We got 1 more item. It requested 1 more item. It got 1 more item. It requested 1 more item. And at this point now we're done. We've got our output at the 3rd index, which is the 4th value output in this stream. And then it cancels the upstream subscription. So I think these types of things are worth paying attention to, and using print and playing with different operators to see how they are requesting values can give you a better understanding of how demand and back pressure work. Okay, so let's look at another example of when you might want a custom publisher. So I have a simple app that I called Photo App, and this is using a collection view that will show photos from the user's photo library in a collection view. And if you haven't used Photo Library before, I'll quickly review how it works. The first thing we do in view.did load is check to see if the photos are authorized. So we have to call this first to see if to request authorization. If we have it already, it will call us back right away and tell us that we're authorized, or tell us what the status is. But if it hasn't prompted yet, that's when you're going to get the prompt. And so we sort of have this kind of nested callback that needs to call load assets if we're authorized. So then we go into this load assets method, and this is going to call fetch assets. And this basically allows you to do a query against the photo library. But in this case, since I'm passing no options, I'm just going to get every asset in the photo library. And there could be many, many thousands of assets here. So instead of giving you an array, it gives you a fetch result. And this whole API is sort of geared around the fact that you may not want to store all of them in memory all at once. So what we typically do to work with this API is we call it enumerate objects, and it will iterate through those and go fetch new ones as needed in the background. And it will deliver you the asset, the index that you're on, and then an output variable that you can set to true in order to stop the iteration if you're no longer interested in new ones. In our case, I know that we have a small amount of images, so I'm just going to go ahead and prepare an array that I want to build up. And this is kind of that pattern that I mentioned a few times in this course, where you're basically having to kind of maintain some state variables. This could be a property on your object, or in this case, it all happens to be inline, so our state can be right here in the method. But we have to kind of maintain the state and sort of build it over time. And so then if we look here, we're enumerating over those, and then inside of here we have an asset, but that doesn't give us the image yet. We have to request that image at a given size. So that's what all these parameters are for. We're saying give me a high quality version of this asset, and if you need to download it from iCloud, go ahead. So it's going to be asynchronous. And so we say request image for that size, and content mode with those options. And then when it's ready, it'll give us an image along with some user info that we can use to know a few things. One of them is whether the image is degraded or if there was an error fetching. And so this image is an optional image. So we unwrap it and then add it to our array. And I'm using a simple model object that will combine the asset and the image. And then finally, we call update with images. So this is kind of the end of the line here. And I eventually want to call update with images with this asset image. And that's going to build the snapshot and apply it to the data source. So real quick, let's take a look at the data flow here. We start with this pH asset fetch result. So it's a pH fetch result. And inside of that, that gives me an array, not necessarily an array, but a collection of assets. And for each one of those assets, I then need to go get an image. So I'll eventually get a UI image out of that. And then I need to essentially convert those two pieces of data to this array of asset images. And then finally, we can call update. So if you visualize it like this is kind of our pipeline of where we started from, what we have, and then in the end, what we need. So I find that Combine can actually make stuff like this a little bit easier to reason about. For instance, if we got an error somewhere in the middle of this whole flow, it isn't really obvious how we might handle that error. Additionally, I don't like the fact that our final, sort of important call is the furthest nested in this block. It's not obvious that this is sort of where we're headed, especially if these blocks start to get even more nested and even longer and more complicated. So for that reason, I think it's nice to explore the opportunity of making custom publishers to not only teach us more about creating publishers, but also to clean up this code a little bit. In this particular example, converting to publishers is just going to be kind of a different style to achieve the same results, but we'll learn a little bit along the way. And once you have a combined pipeline, it gives you more flexibility of how you want to deal with these results over time, rather than just kind of hard coding how we're going to use it in a series of nested blocks. Okay, so real quick, let's just run it so we can see what we're after. Okay, and you can see our collection view, and we just have these 6 photos, but you could imagine, every time you're dealing with these assets, you could think of, what do I do if there's many thousands of them? And so, this approach of building everything up in an array may not be usable for a real app. Okay, so let's start with the most simple basic thing, is this thing right here, where we're getting the request authorization status, and then only if we're authorized do we want to call load assets. So just as an example, we can convert that into a publisher. So let's go over here and add a new file, and I'm going to call this combine plus PH photo library. So we can put all of our combined stuff in here. So we will import the photos framework and the combined framework. Okay, so here we can create an extension on PH photo library, and we can create an authorization status publisher. And before I add the types, let's just see kind of what we're after. This is going to be request authorization. So if we look over here, we're looking for this static function request authorization, and we need this thing right here, which is the status of that PH access level. So we can say for access, PH access level, and this also needs to be static. And that's going to give us a PH authorization status publisher. So let's create an any publisher of that and never. So now we can say request authorization for access, and for our handler here, we'll get our status. So whenever we have a block of code like this where it's going to give us a completion and call us back later, we want to wrap that in a future in order to turn that into a publisher. So we can move this code into the future block and then call promise with success and that status. And it's actually impossible for this to fail, and it's also fits in with the future in that this will only give us a single result. So at this point we are done with the promise, but I don't want the future to be called immediately. I want to make sure that we wait until a subscription happens on this publisher to do the work, because remember, this is actually going to prompt the user for access to their photo library if they haven't granted it already. So that means we need to wrap this whole thing in a deferred, which will defer the work until the first subscription. Then we can call erase to any publisher. And this is the basic structure of that authorization status publisher. Now, if we go back over here to use that, we can say PH photo library dot authorization status publisher for access level. So we'll do read write. And here I just want to filter out until $0 equals authorized. So at this point, now we get a sync, and now we can call self.loadAssets. Okay, we're going to need to store this in our cancellables that we have at the top. And this is our basic structure for that. So at this point, we need to make sure and use unowned self or weak self here so we don't retain self, because this publisher is just going to hang around forever. Because we store it in our cancelable set, it's this publisher is actually, or the subscription is not actually going to go away until the class is deallocated. So we need to make sure and eliminate a retain cycle here. So this gives us a similar structure here, and the gains here aren't really that beneficial, but you could imagine that you might want to do additional logic based on the values coming back from this authorization status. So that's the first one, and that's pretty easy. The next one I want to look at is, let's start from the innermost thing, because we have two asynchronous things that are happening. We've got the PH asset and delivering those results kind of one at a time. And then we also have the PH image manager, which will give you the image. So let's start with PH image manager and make a similar function request image, but instead of calling back with this block, it will instead give you a publisher. So we'll go back over to our combine plus PH photo library, and this time I'm going to create an extension on PH image manager. And here we actually want to create our own publisher. So I'm going to create that publisher next, PH image manager request publisher. This will be a combined publisher. And if we look at the type alias for the output, what types are we going to be producing? That's going to be a UI image. And that means we need UIKit up here at the top. And then a type alias for the failure type. And in this case, we do have failures, and I'm just going to pass along any failure that we get as a generic error. Next, we have the receive method that we need to implement. And so the idea here is that I want to be able to pass in essentially similar options here: the asset, target size, content mode, and request options. So the same exact kind of call site behavior are going to go over here. So what we're going to be calling is publisher for asset, PH asset, target size, CG size, content mode is PH image content mode, and options is PH image request options. And that's optional because you don't have to provide those. So this is going to return an instance of that PH Image Manager request publisher. Now you might be thinking, why am I not using any publisher here? It's because we do know the type of publisher that we're returning. And if we had any kind of extensions on this type of publisher, it would be advantageous for callers to be able to invoke those extensions and methods to interact with this publisher rather than dealing with the type erased version. Now you'd use any publisher when you want to kind of hide the details from the callers. But in this case, I don't think that's necessary. Okay, so what I'd like to do here is just return an instance of that and just literally pass in all of these arguments straight over to Image Manager Request Publisher here. So we can pass in the asset, the target size, content mode, and options. Okay, so going back down to here, now we need to add an extension on this. Extension on our PH Image Manager Request Publisher in order to create our subscription class. So I'll create a final class subscription that takes our subscriber as a generic argument. This needs to implement combine.subscriber, or subscription rather. And again, we're going to need to constrain the S type to match the input and output types. So where s.input equals our output and s.failure equals our failure. So it's going to be basically the same as what we've seen before. Subscriber is going to be optional, and we're going to have all of the same values here passed over to the subscription because that's really where they're used. And then finally, in order for us to support cancellation, which our previous solution didn't support at all, we're going to need to hang on to something called a request ID, which is a PH image request ID. And this is what you would use to cancel any in-flight request. So let me move the mutable versions together, and I'll just paste in a quick initializer to initialize all these properties. Okay, so if you recall, the two requirements for a subscription type are cancel and request with demand. So cancel in the past has been a lot easier because we just needed to set subscriber to nil. But in this case, we also want to cancel any previous image requests that we had. So here we can say if let request equals request ID, then we can say PH image manager dot cancel. Actually, we use the default on here and cancel that image request with that request ID. Okay, so now the image manager code from over here is essentially going to be the same. So let's just kind of copy this and paste it over here. We only want to actually do this if we have a subscriber. So we can say if let subscriber equals subscriber and the demand is greater than 0. Because if the subscriber hasn't demanded anything yet, we don't want to deliver it. So here we can put that inside of there. This is going to be target size. And then this will be our options. So if we get an image, now we just need to send the image to the subscriber. So here we say subscriber.receive, input is our image. Now at this point, it's going to return a new demand because that's the structure of our contract with the combined subscription. So I don't care about that new demand, so I'm just going to ignore it. And the reason I don't care about the new demand is that I have no more values to give. Once I've given you the image, that's it. Now there is a behavior of PH Image Manager that you can request in the options, which is called, let me find out what it's called. If we do options.delivery mode and use opportunistic, in this particular mode, it will actually deliver you a quick low-res result if it has one already handy, and then follow that up with the version that you requested. So this is really, really good in certain situations where you want to show like a lot of images quickly to show some progress, and then have the higher res versions kind of trickle in. And in any image editor where you're loading high-res images, they take a while to load. So if you're navigating between images, it will often show you a lower res one first. In our case, I'm not going to support that because I'm just going to treat this as a kind of one value and then complete. So that's something to consider, that we would have to build that in to this so that we could receive multiple callbacks on this image manager. Okay, so at this point, now we can tell the subscriber that we received our completion and we're finished. So if we didn't get that, then at this point, we can check to see if there's an error in our info dictionary. And info dictionary is optional, but there's a PH image error key that we can look for and see if that's a non-nil error. And if so, we can say subscriber dot or receive completion failure and pass in that error. So that's how we would pass in that error. If we don't have that, then we might just say to receive finished like this, or produce some other error. It's unlikely that you would ever get into this case where you have no image and also no error, but you should do something rather than leave the subscriber hanging. Okay, so I think this is working. So let's go back over to our view controller, and the next step we need to do is this PH asset one. And this one's going to be slightly more complicated. The idea that we want to sort of convey here is that this enumeration is going to be based on demand rather than just enumerating up front. So let's go over to here and let's create another publisher. This time I'm going to call it struct PH fetch result publisher. Now a PH fetch results is a generic type over some object type, and that has to be some any object. So in our case, it's a PH fetch result of PH assets, but it could be collections like albums and things like that. And so this type is actually generic, and so we can make our type generic as well. So that'll be a publisher. Our output type is going to be that object type, and our failure type is going to be never. So we're going to initialize this with a fetch result, which will be a PH fetch result of that object type. And we're going to want to hang on to that. So let's create a property for that. PH fetch results of object type, and then assign it in here. So then we'll receive our subscription, and then we need to do that in there. In fact, I just realized I forgot to do that for the PH image manager request publisher. Let's do that real quick. Create our subscription equals subscription, pass in the subscriber, asset, target size, content mode, and options, and then tell the subscriber to receive the subscription. Okay, yeah, we'll have to do the exact same thing down here, but we don't have that subscription yet, so let's create it. So I'll create an extension on PH fetch result publisher, and we'll create a final class subscription. And it's going to be essentially the same thing as this one. So we can actually just kind of copy that. So you can see there's kind of a lot of boilerplate to do this. Okay, so inside of this fetch result publisher, we're going to need that fetch result, PH fetch result. And we have access to the same generic type since we're an extension on our publisher. So we can do that. And then we also need access to that subscriber, which is an optional S. We're also going to need to keep some state. So we're going to have an integer for the current index. And then we also want to know how many records there are in the whole set. So we can create a count, which is a computed property, and it'll get it from the fetch results.count. We also might want to have a has more results computed property, which will check to see if the index is not the last index, then we have more results to give. So with those out of the way, we can create the initializer. So we'll take our subscriber and our fetch result and assign them. Okay, so we need to implement cancellation and the request for demand. Cancellation is going to be easy. We're just going to set subscriber equal to nil, which will allow us to jump out of any loop that we're in. And before I forget, let's go ahead and create that subscription. Pass in the subscriber and the fetch result. Then we'll give the subscription to the subscriber. Okay, let's move down to the request demand function here. Now this function is going to be a little bit more complicated than the previous ones. That's because we have to manage that loop that the fetch result is going to give us. Now the fetch result does have objects at and object at. So I can get a single object at a given index, or I can get objects at an index set, if I want to say give me like 1 through 5, I can do that all in one go. But I first need to check to see if there are any results at all. Because if this was an empty result, we can complete kind of early and avoid jumping into any loop. So make sure that the count is greater than 0. Otherwise, we can tell our subscriber to receive completion, that we're finished, and then set subscriber equal to nil, and then return. So that's the easy case where we have no results. Next, we're going to take our demand and make a mutable copy of that so we can decrement it as needed. And we're going to enter a loop called while has more results. And we also want to check to see if we have a subscriber here. And if we don't, we want to jump out of this loop already. Okay, so at this point, we have some results to give. And now I want to check to see, should we request more than one, or should we request one at a time? And I could let the demand handle that. So we could check to see the demand.max gives us an integer. If the subscriber had given us a demand of, say, 5, then this will return 5. Otherwise, it'll return nil, in which case the request is unlimited. So if it's unlimited, then I don't really know how many to fetch, so I might as well just say 1 at a time. So I'm going to make this a number of objects to fetch equals that. And we can print out some info just so we can see this working. Requesting up to number of objects to fetch objects. And then maybe we also want to print out the total as count and the index that we're currently on as index. This can be helpful for, especially when you're entering a loop like this, to make sure you don't enter like an infinite loop, which would certainly happen if we had an off by 1 error right here. Or if we forget to advance the index. Okay, so let's make another function here, private function fetch objects. And inside of here, I want to say up to count int, and that'll give us back an array of those object types. So in here, we want to create an index set of all of the indexes from the current index up to that count right there. So we need a end index, which is going to be whatever our index is plus count. But we also need to make sure we don't walk off the end of the array, or walk off the end of the sets. Because if we pass in like, an index of 5 million, it's going to crash. So we want to make sure that we cap this to self.count minus 1. So we can use min to do that. Now, because we're inside of like a combined world, min is actually trying to use an operator min rather than the standard library min. So we're going to need to use swift.min, similar to how we use swift.print up here. So this will give us our end index. And then in order to create an index set, we can pass in a range like this. So let's create a range, which will be our current index up to, but not including the end index. And then we can create the set, which is index set, integers in that range. And then get our objects, which is fetch results.objects at index set. Okay, so now we've got our objects and I want to return them, but I need to be careful because I want to make sure and advance the index at this point. So I'm going to say index plus equals objects.count. So that's really important to make sure we avoid getting in an infinite loop. So back up here, now we need to loop over all of those objects. And we're going to say subscriber.receive input, pass in the one object, because we need to deliver them to the subscriber one at a time. And that's going to give us some new demand. Now, because we're in a loop right here, and the subscriber, say we had fetched 5 objects, but the subscriber canceled after the first one. Well, we need to kind of break out of this. So if self.subscriber is nil at this point, which means we've canceled, then we can break out of this loop right now. Now, this is basically how first works. If we recall from the last video, first will request an unlimited amount of values, but after the first one received, it'll cancel the upstream subscription. So by checking to see if we've canceled, this will allow us to break out early and still honor the contract by not delivering further values. And then if that happened, then, or if that didn't happen, we can add our demand and the new demand together, which will allow us to continue. So then we'll kind of keep iterating through this, keep sending the values. And then at the end of this loop, after we've delivered all the objects that we fetched, we can now check to see if we don't have any more results. This is our chance to finish. So we'll say subscriber.receive completion, finished, and then we'll set self.subscriber equal to nil. Now, it's important to kind of be careful when considering this because this is a tight loop. It will result in an infinite loop if we made a mistake. And so having these print statements in here can help us kind of visualize what's going on in the logs. So I think we're done with this publisher now, but before we continue, I want to create an extension on phfetch results. And I would like to basically say that once I've given a fetch result, I want to be able to just say, give me a publisher for that. So it'd be really nice for me to just say publisher. And then I can say, give me a phfetch results publisher like this. And of course I need the object type. And as soon as I do this, we'll notice this error. Extension of a generic Objective-C class cannot access the class's generic parameters at runtime. So we can't actually do this. And so I can't make a general purpose publisher that uses the Objective-C generic object type. This wouldn't be a problem if we were using pure Swift types, but because this is an Objective-C class, the only way for us to continue is for us to constrain this extension on a specific object type. So if I've specified it up here, now I can use object type like this because it's already constrained to be a concrete type, or I could put phasset in here to make that a little bit more clear. And so at this point now, I just need to return a publisher. And so I can do that fetch results publisher and pass in self here. So this will give us a little bit of a syntax sugar when we're dealing with that asset fetch result. So let's go back over to the view controller, and we have this fetch results, and I just want to delete the rest of this code. And we can delete that to variable. Now when we fetch assets, I can say, give me a publisher. And once I've given the publisher, now I need to essentially map those. This is going to be an asset. And then I want to take that asset and turn around and send it to the PH image manager default publisher for asset. And we can pass in, make sure we are not using the ones that say KVO because those come from Foundation. We want this one that is the one that we just created. So then we can say publisher for asset, target size is our size, content mode is aspect fill, and then pass in our request options. Now at this point, we're returning a publisher from map, which is not really what we want. We want to take the input, the asset, and then subscribe to the result of this so that downstream we get a publisher of images, not a publisher of assets or a publisher of publishers of images. So for that, we're going to change this to a flat map. So now downstream we have a publisher that's going to be producing images that come out of this one. Now at this point, it's worth noting that we probably want to handle any errors that are coming out of this stream right here. So we can actually, on this publisher, I can just say replace error and pass in just a blank image, or maybe we have an error image we want to use. And then I want downstream to actually combine this value with the results of this image manager. So that's done by mapping that, where I can pass in asset here and image is $0 there. So now flat maps output is going to be this asset image, and that's what we want to work with. So if you recall, flat map has a max publishers, which we can pass in a demand here, and I can say, okay, maybe only do 3 at a time because I don't want to overload the system with, thousands of image requests. This allows us to give us that flexibility of how many to do at a given time. So it will, read the assets from here and then, go fetch those images. And then when there's a free slot, it'll go get another one. Okay, so with that in place, now we have an array, or rather a publisher of asset images, and I want to wait until this thing is entirely done so I can get an array of those. And I can do that with the collect operator. Now this is kind of what I was mentioning, that it works for a small amount of images. You wouldn't want to do this if it was a huge set of data, because you would end up with waiting for the entire array of thousands of images, and then you would be overloading memory, etc. But in our case, this is an easy thing for us to do now, but it's also potentially easy for us to fix later. And if we just wanted to get the first one out of that collection, we could just change that one line of code, and now we've got the first one. Or if we wanted to get a certain number of them, maybe we only want up to 100, so we could say prefix 100, and after that, it's no longer going to be subscribing to any further values after that. So this gives us kind of a quick and easy way to change the behavior of our program because we're using a combined pipeline. Okay, so once we're done collecting all of this stuff, at this point we want to make sure that we are on the main queue. So I'm going to say receive on dispatch queue.main. And then here I'm going to say sync unowned self in, and then we will call update with those images. Take those images, and this gives us an array of asset images. And then finally, we can say store in cancellables. Let's go ahead and run it and make sure it still works. And it looks like we're missing one image from the list. And looking at the output here, we can see PH asset got a request for 3. Then it received some values, 3 values here. And then we are on index 3 and we said, okay, give me 3 more. So then it received 2 and then finished. So there's something wrong about our loop here. Let's go back over to this one. And we can actually set a breakpoint in here, right inside this loop. Okay, so we're inside of here and we have the number of objects to fetch, and that is 3. And that's because our flat map is requesting 3 maximum items at a time. Then we're going to fetch the objects at that. So let's just check the range that we are building here. So that's 0 up to, but not including 3. So 0, 1, and 2, that's correct. Then we get the number of objects, and there are 3 items in there. So our index advances now to be 3. And then we continue. We send it, we add new demand if we have any. And this is the third one. Okay, so at this point, we still have more results. So we're just going to continue in the while loop. And at this point, number of objects to fetch should be 3 again. And we'll go into that fetch. The end index at this point is 5. And so our range here just becomes 3 and 4. So this is actually incorrect. We want our end index to be the count, not count minus 1. And that's because we're not including it here. If we were including it here, then that would be the problem. So because index plus count ended up being greater than count, we ended up getting 5 from count minus 1. Okay, so let's run it again without that count minus 1. Remove our breakpoint. And now we get our 6th photo. So this is what I was talking about, where you can end up with something that looks to work, but has some subtle bugs. So it's important to validate that. Okay, so that was an exercise in creating some custom publishers for working with PH assets and the photo library. Okay, there's one more custom publisher that I want to cover here, and this is because this one is going to be probably pretty useful when dealing with UI. Now, I mentioned at the beginning of this course that Combine doesn't really ship with anything that binds it to your user interface and kind of leaves that to the community to build something. So we can do that. I'm going to use this example here where we have 3 sliders, and I'm going to use that to control the color of the background of this view. So to do that, rather than subscribing to each one of these and having a method or an IB action method for each one of those, we're going to use Combine for this. So I'm going to create our UI control publisher because I want this to work with any kind of UI control, and that will be generic over that type of UI control. This is going to implement the Combine publisher protocol. And so we're going to have an output type. And for the output type, it just depends on which control you're using. So I'm just going to pass in the control itself, and anything downstream can just map this control to whatever its value is. So if it's a button, it's probably going to be void or something else. If it's going to be a slider, it's going to be a float, but it doesn't really matter. So then we have a type alias for the failure type. And in this case, we're dealing with UI controls. Our failure type is going to be never. So when we initialize, we're going to be taking in the control and an event, and that's going to be UI control.event. So this is things like value changed or touch up inside. So let's quickly create some private variables for these and assign them in the initializer. Okay, so next we need to implement the receive method. And at this point, this is all going to be basically review. We're just kind of repeating the same patterns. Let's make an extension on our UI control publisher. We'll create a final class subscription here. And this will be generic over our subscriber. This will implement the combine.subscription protocol, and then also constrain S to have its input type equal our control in this case. We can use control or output, doesn't matter because those are the same. And we'll also constrain this where the failure type equals our failure type. Okay, so we're going to basically need these same things here. We'll need those, and then we'll also need the subscriber, which will be an optional S. So then we can initialize this, take in the subscriber and the control and the event. So we actually don't need to keep the event here, because what I'm going to do is we're going to set the subscriber equal to subscriber, set the control equal to control, but then this is where we're going to actually wire up our target action on that control. So I'm going to say control.addTarget, and this time we're going to add self. So self becomes, the subscription becomes the target for our control. So whenever that event fires, it's going to invoke a method on this subscription. And we haven't made that selector yet, but this is where control event comes in. So we don't actually need to save it because we only use it in this one place. So next, let's look at the function we're going to use for handle event. And this needs to be marked with Objective-C so we can use it as a selector like this. And we'll say handle event. So now we know, assuming this is like a button, for instance, every time we tap on the button, it's going to call handle event. And handle event is where we're going to send our values to the subscriber. So this one is slightly different in that we have those methods that we need to implement, cancel and request demand. So cancel is going to be exactly the same as what we've seen before. We just nil out our subscriber. Now, we would also have the option of saying control.remove target action for. And in this case, we would need to hang on to this event so we could remove ourselves as the subscriber for that. But as it happens, because we release subscriber, subscriber will release its hold on the subscription, and then everything gets cleaned up. So once subscription goes away, it will actually remove this from itself, because the target on control is a weak reference, which means that when it goes to nil, it will remove its actions automatically. So at this point, now we have this request demand, but what do we send here? Because we don't have any values. This is completely driven by the control, not by when the values are requested. So the only thing we can really do here is hang on to the demand. So I'm going to make this private var demand, which is subscribers.demand. And that's going to be optional because we don't have one at initialization time. When we get one, now we can just set self.demand equals demand. And so the subscriber could demand one value or 5 values or unlimited values or no values. And we don't want to send these values in this handle event if we don't have any demand. So here we can say guard let subscriber equals subscriber. So this means we haven't canceled. And then we can also check demand greater than 0. And if either of those things are false, then there's nothing for us to do. We need to unwrap that demand because we may not have the demand. So we could say let demand equals demand, and then comma demand greater than 0. Okay, so in here we can say subscriber.receive input, and that's just going to be the control itself. Now at this point, we get back our new demand, and we can set self.demand plus equals new demand. And because that's optional, what we're going to have to do is kind of set that equal to the unwrapped demand that we got, which is this one, and add it this way rather than just using plus equals. So that will set the new demand. So this way, if the subscriber wants one at a time after it receives an event, maybe it asks for one more, this would support that type of setup. Okay, so then back up here in our UI control publisher, we now just need to create an instance of this subscription. And we pass in a subscriber, which is subscriber, control, which is the control that we have, an event like this, and then tell the subscriber to receive this subscription. Okay, so we finished our custom publisher. Now at this point, I'd probably move this into, another class or another file, and maybe even another framework that we can bring this between projects. But I'm just going to leave it in the same file for this demo. So at this point now, I want to sort of observe these sliders, and ultimately I want to get a color out of that. So what I would have to do is create a publisher for each. So I'd have like the red publisher would be a UI control publisher for the red slider, and the value changed would be the event. Then once I do that, I can map that to its value. So I get the 0 to 1 range of this slider, and then I can do something with this value right here. So in this case, I would probably take this because I want to kind of abstract away these details and just have kind of a publisher of floats. So I might create a private variable for this, for a computed property that returns this any publisher of a floating point value. But I think we can do a little bit better here. If we want to wrap this and automatically get an easy publisher for any control, one way you might think to do this is to create an extension on UI control and just make it, or just to give it a publisher. And I'm going to make this a function, so we can say publisher for event and pass in UI control dot event, and this would return a UI control publisher for self, basically. But the problem with this is, at this point, we're extending UI control, and we can't use self here because we don't know what self is when we're extending UI control. So this is where we have to do a little bit of a protocol dance with Swift. So I'm going to create a protocol here, control publishable, and this will just be empty. So this is just kind of like a marker protocol. Then we can create an extension on control publishable where self inherits from UI control. And we can move this publisher inside of there. So now at this point, self is some concrete type that implements UI control. And finally, we can create an extension on UI control and make it control publishable. So this sort of dance we have to do to satisfy the type system. But at this point now, any UI control we can call publisher for event, and this is just going to turn around and call UI control publisher. The control is self, and the event is the passed in event. Okay, so this is pretty nice. It gives us kind of a lot of bang for our buck because we can now say r.publisher for, and we have to be careful not to use the key path or any of those. We want the publisher for event, value changed, and now that's pretty nice. It's easy to work with, gives us our value. And I want to take those values and I want to turn them into a color. So I've got a red, green, and a blue one. So let's create a computed property called color publisher. This will be in any publisher of type UI color, optional. And the reason I want optional is I want to assign this to the background color of our view, which happens to be an optional color property, and never. So what I want to do now is anytime any of these change, I want to get an event and combine the latest values from all three. So we can use publishers.combine latest 3. And that gives us 3 slots that we can put in. So we have 3 publishers. So we can put in r.publisher for value changed, and again, g.publisher for value changed, and then finally b.publisher for value changed. Okay, so at this point, we need all of these to map to $0.value in order to get their floating point value. And we could do it like this, which is fine, but I think that this is probably worthy of yet another extension. So we can make an extension on UI slider and just make ourselves a slider publisher. Or we might even just call it value publisher. This will give us an any publisher of floating point values and never. Now, the reason I want to do this is so that we can kind of embed this idea where I can say, take publisher for event value change. So we kind of embed that. logic, map this to $0.value, and then erase to any publisher. So inside of here, now each one of these, instead of becoming like that, it would be r.value publisher, g.value publisher, and b.value publisher. Next, we can take that and map this. We'll get the values, which is going to be a tuple of all these floats. And I need to return a UI color here. So this is going to take the red, green, blue, and alpha. So I need to cast these to a CG float. So I'll use values.0, and I'll just repeat this pattern for the next one using values.1 and values.2, and we'll use 1.0 for alpha. So at this point, I want an optional color, so I'm just going to say as UI color optional. And I've done this a few times in this course already, so when dealing with UIKit, I think that maybe a case could be made that you want an operator that just says make optional, which would essentially do exactly this. So that's something that I'll leave as an exercise to you if you would like to create that. I think it would be probably pretty useful. Okay, so inside of here, we've got our UI color, and now we want to erase to any publisher. And if we do a build, this should succeed. So now I can take our color publisher and we can assign this to the background color on our view instance. And then finally, we will store this in our cancelables. Okay, so with this in place, let's give this a run. And so now we have our three sliders here, and you can see that we have them here. If I change them, they don't seem to be working, but if I change all three of them, it sort of snaps into gear. And that's because the combined latest three, or all of the combined latest publishers, will wait for a value from all of its subscribers or all of its publishers that it's watching in order to get one value as soon as they all have a value. And so in this case, it actually is not good because I want to get a value when any of them change. Now, because these sliders inherently have a value already, sometimes it can be advantageous for us to send the initial value right away. And I think that works for basically any control with the exception of buttons. So you may want to make a special case for that. But in some cases, we might want to allow our UI control publishers to just go ahead and send an event right now. This would be useful for switches and sliders and things like that. But for things that have side effects, it may be dangerous, like buttons, where you might be triggering some action that you don't want to. So it depends on how you want to handle this. You could pass in a value to say send your value initially. One other way we could do this is special casing our slider in this case. You can see that we're already sending a value publisher for value changed. And what we can do is merge this with our value now. And this makes sense for a slider, so we could do this. So we can merge this with just value, which is the value that we have at the time this publisher is created. That's going to give us a single value now merged with any value that happens from our event. Now I do need to switch these around because we want to map this to value first, and then merge with a publisher that has the exact same signature. And we need a with in there. But now we have a value publisher. As soon as we subscribe to it, we'll get the value that it is now, and anytime value change, we'll get the value as it is in the future. So with this change, we've fixed that bug. And now you can see actually the view started off with this kind of gray color because it gave us a value immediately. And so now we have our UI control publisher that is allowing us to observe these events. So far in this course, we've seen many examples of how to use publishers and operators in order to create a pipeline of functionality that we need for our applications. We've also seen how we can wrap existing functionality into an operator, and I use that in air quotes, in order to give some functionality a new name and to reuse some common logic. And we've seen that by creating extensions that create what look like operators in order to customize how we use Combine. We've also seen how to use custom publishers to create publishers for things that don't already have them in the system. But there may be a time when we want to actually use an actual custom operator, and this is where things get a little bit more complex, but you also have quite a bit of flexibility. So before we get started on a custom operator, let's quickly review what we have when we talk about a subscriber and a publisher. So the order of events here is we call subscribe and pass in an instance of the subscriber on the publisher. And as we've seen in the previous example, the publisher will create an inner class that it uses to do its actual work. And this class conforms to the combined subscription protocol. The subscription is then passed along to the subscriber, and the subscriber maintains access to that subscription, and the subscription will then deliver values to the subscriber, handle demand, and handle the completion or failure events as needed. So when we put an operator in the middle here, it's actually the exact same process. The subscriber subscribes to the operator instead, and the operator turns around and subscribes to the publisher. The publisher creates a subscription class, passes it downstream to the operator, and then the operator creates its subscription class. And at this point, the subscription class maybe is a bit of a misnomer because it's not only a subscription, but it's also itself a subscriber. So as you can see, the operator kind of sits in the middle here. It acts as a subscriber and as a publisher. So when a publisher emits its values, it's emitting it to the operator's subscription class, and then that is delivered downstream to the subscriber. So a better way to look at this is the operator has some inner class that does its work, which we're calling subscription so far, but we may change the name to something a little bit less specific. And then we need to give it a reference to its publisher, which we're going to call upstream, and a reference to its subscriber, which we will call downstream. So as you can see, an operator has a view of its world completely up the chain and down the chain, and any operators that we insert in between are going to operate in the same way. So when a subscriber requests demand, the operator can turn around and request demand from the publisher. When the publisher emits a value, the operator can turn around and deliver that value to the subscriber. But this is where the interesting logic can happen, because the operator can decide to do something different. It can choose to eliminate results. It can choose to delay the delivery of those results. It can choose to transform those results in some way, or maybe collect a buffer of those results before delivering them to the subscriber. So this gives you a lot of flexibility and the opportunity to do some really interesting work and encapsulate it up into what looks like a simple extension method on publishers. So to drive this home, let's look at a concrete example. So here I have a simple publisher that will just print out all of these values or emit all of these values. And our sink is empty right now because it is not important to the context of this discussion. What I want to do is create a custom operator here that we're going to call Shiny Operator. Now, Shiny Operator itself needs to be a publisher. And it needs to be generic over some upstream publisher type as well, because we need to be able to pass in that upstream publisher to the operator. Now we also have the generic arguments of output and failure type, which are just going to come from the upstream publisher because we're not altering those in any way. So here we can say upstream output and failure, or our output and failure equal the upstream's output and failure. Now, if we were creating a different type of operator that transformed the output and had a specific output type, then we would use that here. But because our operator is essentially a pass-through operator, we're just going to use those same associated types. Okay, now the job of this Shiny operator is just going to be similar to the print operator in that it's going to print out values, but we're going to wrap that in some emoji sparkles to make it shinier. So this will serve as a really contrived example to show how we can create a custom operator to do this. So let's use the fixit to create this receive method. And this is where we need to return a new subscription. And in the past, this is where we've created an extension on our publisher type. And in here, we'd create a final class. And I called this subscription before, but this time I want to call it operator because I want to avoid using the word subscription because it's not just a subscription anymore, it's also a subscriber. So I'm going to call this final class operator, and this is going to be generic over the subscriber type, just like before. And it will implement the combine subscriber protocol and the subscription protocol. So it's going to look like this at some point, but I'm going to start with just the subscription so we can focus on just the generic requirements for that protocol, and then we'll add on the subscriber so it's a little bit easier to understand where each piece comes from. Okay, now this is going to be similar to what we've done before, where the subscriber's input must equal our output, and the subscriber's failure type must equal our failure type. Now if we apply any fix-it here, let's give ourselves some more room. Now we can see request demand and cancel, and these are going to be the requirements for the subscription protocol. Next, let's add in the subscriber protocol. Now that's going to require us to take in a generic argument called input, and then we can constrain our input equals the subscriber's input so that they match up. Now at this point, it's asking us for the input and failure type to be specified here, but these should be specified already. I'm going to use the s.input and s.failure to satisfy the compiler, but once we're done, we should be able to delete these if we've fully specified it here. This seems like perhaps a playground bug. So then I hit fix it again, and now I get these three receive methods, which I'm going to move down. Let's create another mark here for the subscriber methods and paste those in here. Okay, so now we have our basic template here, and we now need to go back up here to create an instance of our operator. And this needs to take that subscriber, so let's add that in here. We'll have our subscriber, and this is what we used to call var subscriber s, like this, but instead I want to use the terminology downstream here, because we also need an instance of our upstream, which is going to be our upstream publisher type. And that can also be nullable, because when we clean up, we'll need to set both of these things to nil. So when we create our operator, we need to pass in the subscriber. So we'll say init subscriber. And for this, I'm going to use the downstream terminology, which will be s. So we can say self.downstream equals downstream. Okay, so now we have the downstream in the initializer. We can pass in subscriber as our downstream. And normally this is where we would say subscriber.receive and pass in the subscription this way. But instead, we need something to turn around and subscribe to our upstream publisher. Otherwise, if we just handed it subscription, we're going to be sitting there never delivering any values. So we actually need to subscribe to upstream. And this is where we're going to do it. We're going to say upstream.subscribe and pass in operator as the subscriber. Now, if you recall from the lifecycle, the next thing that happens is the upstream is going to create its subscription and hand it to the subscriber, which is us. So if we go down here to where we receive our subscription, this is where we can specify that. So our upstream here is actually going to be an upstream subscription, not an upstream instance itself. It's going to be whatever type that comes in. So what we can do here is we can hang on to that when we receive it. Upstream equals subscription. And then we can tell our downstream that it's ready to receive a subscription, and we pass in self here. So this is an important distinction. This is where we get access to our upstream subscription, and we need to hang on to this. And then we pass ourselves as our subscription for downstream. Okay, at this point, the downstream subscriber is going to request demand from us. And because we don't really need to do anything interesting here, we need to turn around and request that same demand upstream. So we're going to say upstream.request and pass in demand. Then we can start receiving values from the publisher that's upstream from us. And we need to turn around and send those values downstream to our subscriber. But before we do that, I'm going to call swift.print, and we're going to pass in some emoji sparkles here and output the input directly in the middle of that string. So now we need to return some demand, and because I don't really want to do anything interesting here, we can say downstream.receive input, pass in the input that we received, and because this is an optional instance, this could be nil, and so we need to fall back to some demand, and I'm going to fall back to something that just never increases the demand. So .max0 will not add anything to any existing demand. So it's at this point where if we needed to do any kind of delay before sending the value downstream, if we wanted to implement some sort of debounce timer, we could do that here. We could transform the value here by applying a map function. We could do whatever we want here. But in our case, our custom logic is just one line of code here. Okay, then the publisher could complete either with an error or by completing normally. And so we need to tell that the downstream to receive that completion. And once we've received completion, this is our chance to clean up. So we can set upstream equal to nil and downstream equal to nil. And I'll copy that because we have to do it one more time in the cancellation. The cancellation is happening in the opposite flow. It's happening from the bottom up. The subscriber is telling its upstream to cancel. So in this case, we need to tell our upstream to cancel and then clean up. So let's take a look at what we have, make sure we don't have any empty methods. Everything seems to be implemented correctly. So now if we go back down to where we're using it, we want to use the nice syntax sugar of just being able to apply an operator right in the middle there. So to do that, we'll create an extension on publisher. And I'm not constraining this to any output or failure type because I want it to be accessible over any publisher. I don't care what the output or failure types are, so that we don't need any arguments there. And then we can create our Shiny function, which returns an instance of our Shiny operator. And remember, Shiny operator is a generic over the type of publisher that is upstream to it, which in this case is just going to be self. So now we can return Shiny operator upstream self, the instance. And with this little wrapper, now we can use it in this way, and we run it. And here we can see that we get our output from our operator, and it's acting as a publisher and as a subscriber. So there is quite a bit of boilerplate going on here. In fact, you could essentially use this as a template for any future operator that you want to create and just change any of the behavior that you need because you have hooks to do that. You can change the demand if you want to here. You can change how cancellation works here. You can change how you receive the subscription if you needed to. For instance, maybe you want to be on a different queue when you subscribe, which we've seen with the subscribe on scheduler operator. We can change how and when to receive the inputs or even change the values of these inputs. We could change the queue that we're on, as we've seen with the receive on operator. Or we could delay the delivery of these values by using a scheduler to delay that, like dispatch queue.main.async after, for instance. And then when we receive our completion, we could do something custom here if we needed to. So in our case, really, this is all just boilerplate with the one exception of this line here. And so this gives us a good idea of how to create a custom operator. And as you see, it's a little bit more complex, but it also gives us the ultimate flexibility of how we want to, implement our behavior. Okay, now that we've seen how to extend, combine, and create our own publishers and subscribers and operators, let's take a stab at recreating something that exists in the reactive Swift and RX Swift world, but doesn't exist by default in Combine. And this is because Apple just chose not to implement this and ship it as part of the framework, but we can create it ourselves. So one example of this is an operator called amb. And amb is short for ambivalent, which means that it will take two or more source publishers, in our case, and it will emit all of the items from only the first of these to emit an item or an event, a finished or completion event. So in this example, in this marble diagram, you can see that there are three upstream publishers, and then there's the amb operator, which is operating on all three of them. And what we see here is that the first one to emit a value is the only one that this one emits downstream. So if I were to move the 20 ahead of the first one, you can see that all of the items switch to be the first stream. And if I switch this one to be the first one, you can see that. And then also, if you notice that if we end up completing first, well, I guess I can't show you that example here, but if we end up completing first, then the downstream will get a completion event first and not emit any values from the other ones. So this is the operator that we're going to create in this episode. Now, you might ask, what am I going to use this for? And these are kind of those things where one day you might sort of notice a scenario where this type of operator would be helpful, and it would be nice to know that it exists. But one of the things you can use this for is to essentially race multiple streams. You might have, say you're getting hotel prices from different providers and you just want to get the first one. And so in that sense, you could, say go fire all the requests and only take the one that first came back. Another thing you could use this for is to essentially time out operations. You could say, start some stream on this one, but then have this one sort of delay for a bit. And then complete, which would essentially allow you to time out the operation above. So AMB is sort of low level, and it's something that you might find use for. But I think the requirements are pretty straightforward. We need to take some upstream publishers, and we need to subscribe to both of them and only emit downstream events from the first one that essentially emitted a value or a notification. So let's go over to Xcode. And we will create an extension on the publisher's enumeration. This is essentially like a namespace, and we can create a struct called AMB, which is a publisher. So this way we can use it like this, like publishers dot, and now that we are sort of alongside all the rest of the publishers, and it makes a little bit of sense of what this is. Now AMB is going to be generic over two types of publishers. So we'll have first and second. And I'll talk more about how you can have more than two later. So what we need to do is constrain these because they all need to be the same type. So we're going to have to say where if the first output type is the same as second's output type, and first's failure type is equal to second's failure type. Now I also need to constrain my output type. And in this case, I can just use first output because they're going to be the same. And I can use failure type as first.failure. Then let's create a first and a second instance that we're going to hang on to, and an initializer here to save those both off. Okay, so now we need to implement the receive method to create a subscription and pass it to the subscriber. So in this case, we're going to have an extension, and we can make this a private extension on publishers.amb. And this time we can create our final class subscription, which will be generic over our subscriber type. And then we can also constrain that. So the subscriber's input must equal our output, and the subscriber's failure must equal our failure type. Okay, we're going to need to take the first and second upstream publishers, as well as the subscriber. So we'll say var subscriber is an optional S, and we will take that in here as the subscriber, and set subscriber equal to that. Okay, and then before we forget, we need to make sure that we are a combined subscription. And that will allow us to implement the cancel and the request demand methods. Okay, so now we've got our subscription. We can go up here and create the subscription. Is an instance of subscription, pass in first, second, and the subscriber, and tell the subscriber to receive that subscription. Okay, so back down over here in our subscription, we need to do a few things. One, we need to subscribe to both of these. So we're going to do that inside this initializer. And the question then is, what are we going to subscribe with? We could create another subscriber type in order to sort of customize everything. But in my case, I'm just going to use a sync. And we're going to create a sync for each one of these. So this is going to be subscribers.sync. And the type is going to be output and failure. And we'll do the same thing for sync2. And these are going to be optional because once I receive a value from one of them, I need to cancel the other one. So now we have enough sort of data here to say that, oh, okay, when we cancel, we actually want to call cancel on both of those syncs and nil them out. So we can say sync2.cancel and sync2 equals nil. Now this is a little bit different than the any cancelable in that I'm going to explicitly call cancel on this because this is a subscriber itself. It's not returning the any cancelable instance, which we can just set to nil. And then finally, we need to set our subscriber to nil so that it will release its hold on the subscription and then clean everything up. Okay, so at this point now we can subscribe to it here, but there is a little bit of a problem. And let's just start off by creating our first sync subscriber. And we'll receive completion and then the value. So at this point, we would be passing the value downstream. So we need to send that value downstream. But in this case, we haven't received any demand yet because we haven't received this. So we basically need to wait to subscribe to these until we actually have a demand. So I'm going to move that off into another function called start syncs. And what we're going to do here, so we create sync 1, and then we say first dot subscribe and pass in our subscriber sync 1. And I need to force unwrap that since it's optional. Now I'll need to do the exact same thing for sync 2. And then say second dot subscribe sync 2. Now I only want to do that if our demand is greater than 0. So we'll say guard demand greater than 0. Otherwise we will return. And if sync 1 is nil, that means both of them are nil, then we can call start syncs. Okay, so now we've subscribed to both upstream publishers, and we're not really doing anything with the demand at this point, so we probably need to hang on to the demand as subscribers.demand, and I'll make it optional. And then down here where we're getting this, we will say self.demand equals the demand we received. And at this point, I'm going to avoid figuring out which one is the winner, and we're just going to start sending the values downstream. So let's ignore completion for a minute, and we'll just send these values downstream. So we will say subscriber, and to do that, we will need unknown self here. We'll say subscriber.receive value, and then we can do the same thing here. In fact, the entire sync itself is exactly the same. Now it's saying the result of call to receive is unused because when you receive a value, you get additional demand, and we need to add it to our demand. And we also need to make sure that our demand, we can say guard let demand equals demand. If we got any values and we didn't have a demand, that means we never received any, and we just need to ignore this value so we can return. And we also want to check that demand is greater than 0. So if we've done that, then we need to set our demand to be the addition of the existing demand plus whatever we receive here. And because this is nullable, we'll also need to make sure that we have a subscriber like this. Otherwise, we can return. And that will allow us to avoid the nil there. And now we have guard let, or now we have a demand that is non-nil, and let's just copy and paste that. Okay, so when we request, or when they request demand, we will start the syncs, and those values from the upstream will be sent downstream like this. So where we're subscribing here, to make this a little bit easier, we're going to print out first and second here. And then let's go ahead and create a quick harness that we can use. And we'll use a subject for this. We'll say pass through subject of int and never, and we'll create 2 of those. And then we'll create our publishers.amb. And we'll pass in first and second, sub1 and sub2. So at this point, we need to subscribe to that. So we'll use a sync for that. And when we get a value in, we'll just print out that we received that value. Okay, so at this point, we can say sub1.send1, sub2.send 10, and then we'll send 20, and then we'll send 2. So I'm doing this a little bit so it's obvious which one is the values are coming from. The 10s and 20s will be coming from subject 2, and the single values will be coming from subject 1. And let's go ahead and create our, hang on to the cancelable that comes out of that. And now we can see what happens here. So first receives its subscription and we request unlimited values from it. And then second, same thing. We start passing values here. So first receive the value 1 and you can see it passed it downstream. Second, receive the value 10, passed it downstream. So we basically have everything we need here. And then at the very end of this, we can see that both of them received cancel because the playground finished. So that's correct. And what we need to do now is figure out, okay, when we're doing these syncs, we need to make sure that we only send it if this sync is the kind of the winner. And so what I would like to do now is we could create an enum called winner, and we can have a first and a second here. So at this point now we can check to see if we have a winner before sending values. And at this point you can see there's duplicate code. These are identical with the exception of where it's going. So all of this code can now go inside of a method. So I'm just going to make that now. Private func build sync. And this will return subscribers.sync of output and failure. And then we can just paste this in like this. So now this is going to be build sync, and this is going to be build sync. Let's delete this. So what I need to do is just identify these as first and second, like this. So we'll pass this in as which type is this? It'll be one type of winner. And we can pass that in there. And now we want to basically say that we want to essentially only pass this along if this is the winner. So let's create a function called dispatch. And this will take some block, and we can just use void to void for that. But if this is the winner. So the first thing we need to do is check to see if our winner is nil. That means we haven't decided yet. And so there is no winner. At this point, we are going to become the winner like this. And now we can check to see guard self.winner equals this winner. Otherwise, we can return and ignore it. And now we can pass in the block. And this will only be called if we are the winner. But it also has the side effect of assigning the first winner. So now when we have the value here, we can call dispatch if and pass in a block if we are the winner, and we can pass in the winner there. So I can put this inside of that block. And so now we essentially need to do the same thing for completion. So we'll say dispatch block if winner. And now here we can set to see if the subscriber that we have. So we can say subscriber.receive completion, completion. Okay, so in this case, now we need to have unknown self inside of here so that we can call dispatch. Okay, so now if we run the same example, we should see that the values we get downstream are 1 and 1. Actually, that should have been 2. We should see 1 and 2 downstream, and it's ignoring these values 10 and 20 because those are no longer the winner. So what we need to do now is cancel the one that didn't win. We need to cancel the loser. So I'm going to do that over here on a did set, and we can say if let w equals winner, then we can switch on w. And in the case of first, we need to cancel the other one. So we'll set sync2 cancel, and sync2 equals nil. And in the case of the second, we need to cancel the first one. So sync1 cancel, sync1 equals nil. Okay, so now we should see that cancel happen if we run it. First and second requested their values. First received value 1, second received cancel. And so then we only get the values there. And then if we say that subject 2 completed with finished and subject 1 completed with finished. Now we can see first received finished. So now we can see our completion events are coming through as well, just like we want. And if I change the order of these, so subject 2 emits first, now we should see the values from subject 2, 10 and 20, 10 and 20, and second receive finished, first receive cancel. So this is working as we'd expect. What I'd like to do now is have an extension on any kind of publisher and have a func called amb, which takes in some generic other, which is a publisher. And here we can take in other like that. And we need to constrain this to make sure that the other publisher, so other.output equals our output, and other.failure equals our failure. So as long as those types match up, we can call amb on it, and this will return publishers.amb with self as the first type of publisher and other as the second type of publisher. Now we can just return publishers.amb. For first, we'll pass in self. For second, we'll pass in other. And I need to move these generic constraints over here. And now we're compiling again. So what we've done there is just added our sort of operator syntax sugar so that instead of doing this, we can now say sub1.amb sub2. And we essentially get the same results, but with a little bit easier to write. So now what would we do if we had a third subject? So let's grab subject 3 is a pass-through subject of int and never. And for this one, let's say sub3.send 100, and we'll send a couple more values, 200 and 300, and we will send the completion finished. So now we've got a third subject. How do we match that in here? Well, as it turns out, it doesn't really matter what type of publisher is in the second slot here. It could itself be recursive and use another amb publisher. So the second argument would be racing amongst those two, and the winner of those two would be racing amongst the first argument. So we can sort of use a tree here. So sub2.amb sub3 becomes a new publisher, and that gets amb with sub1. That's a little bit hard to say, but the idea here is that we should still get the same values here. The output will be a little bit hard to read because first and first we'll have second, second, and second because the other one has itself a first and a second. So, but what we need to focus here are on the values. We receive a value of 100. The first publisher here ends up canceling. And then the first one in the other slot also gets canceled because sub3 is kind of in the rightmost slot. So if we think about this as like a tree structure, we have the A and B at the top, but B is actually comprised of C and D. And so in our case, D is sub 3, C is sub 2, and B is the publisher that is racing those two, and then A is sub 1. So when D emits its first element, B notices that and cancels C, and then we have B ends up emitting its value, so it wins, and the outer publisher will cancel A. So that's kind of the tree structure that we have here. And so with this type of structure, we can essentially run the same algorithm across any number of publishers. So there are a few drawbacks to the approach that I have right here. And let's take a look at those real quick. The first one is that right now we're using a built-in subscriber, sync 1 and sync 2. And we're doing that just to make the example a little bit easier. But the problem with the sync subscriber is that it requests unlimited values. As you see here, we are requesting unlimited values from first, which is our first upstream, and unlimited values from our second, which is our second upstream publisher. And the problem with requesting unlimited values is you can never go back. And so if our downstream subscriber couldn't handle unlimited values, we've sort of broken the contract. We are not really honoring the demand even though that we are saving it and we're sort of maintaining it, we're really only making sure the demand is greater than 0 before we send it. The better approach is for us to be requesting just a single element from the upstream subscriber, because that's really the one that's going to decide which one we listen to from that point onward. And we can't really do that by using the built-in sync subscriber. So I bring up that limitation because I wanted to take a look at this Combine community project called Combine EXT. And if we take a look at the sources here and look inside of operators, you can see that there's a whole bunch of community provided operators that sort of fill in some of the blanks that you might come to expect if you've used one of the other reactive frameworks. And AMP is one of those. Now, if you take a look at the source code for this, this was definitely the inspiration for this particular video. But if you look at the implementation of this one, this uses something a little bit different than what I did. So what we're going to take a look at down here is the subscription class, which is similar to what we created. But in this case, they're using a Combine EXT class called Sync as its subscriber. So if we take a look at if we go into sources and common, there's something called Sync and Demand Buffer. Sync is essentially a generic type of class that is essentially what we were creating, we were using Sync for anyway. And this one lets you create a sync that will subscribe to the upstream and pass values to downstream and give you a chance to transform the output or transform the failure if you really want to. Additionally, this creates what's called a demand buffer. So the demand buffer will essentially hold on to any demand from the downstream subscriber. So we can see that when we receive our subscription or when we receive our values, it is just passing that off to this transform input block and then adding it to the buffer. If we take a look at demand buffer, we can see that this guy is a buffer responsible for managing the demand of a downstream subscriber for an upstream publisher. So this is essentially what we've done in every one of our custom subscriptions, is we've had to essentially manage the demand on our own. So I think this is a good case study to take a look at. And this would essentially allow us to request just a single value from the upstream publisher, because in the sync case, you can see that Sync takes these values, but is also a subscriber in itself. So you can tell it to request a certain amount of values from its upstream publisher. And you can inherit from this to customize the behavior if you need to. And so we can take a look at the sync here. You can see that their sync inherits from combineext.sync. And so it handles a lot of this boilerplate for us, but allows us to do things like request just one element from the upstream publisher. And this is essentially the limitation that we had when we used the built-in combine sync, which will request unlimited items. So I encourage you to take a look at this implementation. Combine EXT is just full of other publishers that you may have seen from other frameworks. And it's definitely a good way to learn about Combine by seeing how things are implemented in here. And of course, there are tests for all of these as well.